We all use the internet every single day, right? But have you ever really stopped to think about what's actually happening under the hood? Well, that's what we're going to do. We're going to take a little digital road trip to follow your data on its insane journey, from your keyboard, out across the world, and all the way back. Let's dive in.
It just feels instant, doesn't it? You type in a website, you hit enter, and bam, the page is just there. But in that tiny split second, an absolutely incredible chain of events kicks off, sending your request flying across a global network and back again. So let's trace that exact journey, step by step. Okay, so first things first on our trip, we need an address. Your computer, see, it doesn't get website names like example.com. It only speaks in numbers. And that's where this amazing thing called the Domain Name System, or DNS, comes into play. You can basically think of it as the internet's own giant GPS.
Yeah, this whole phone book idea is just perfect. I mean, think about it. You know your friend's name, but you probably have no idea what their actual phone number is, right? You just look them up in your contacts. DNS is exactly like that, but for the entire internet. It looks up the name you give it and finds the specific number, the IP address, that your computer needs to actually connect. It's the essential translator between our world and the machine's world.
And get this, it's not just one simple lookup. It's more like a super fast four-step relay race. First, your request shoots off to a DNS recursor. Think of it as a helpful librarian. That librarian doesn't know the answer, so it asks the main index, the root server. The root server points to the right section, maybe the .com aisle, which is run by the TLD server. Then that TLD server points to the exact book on the shelf, the authoritative name server, which finally has the IP address you were looking for. And all of this happens in just milliseconds. It's wild.
All right, we've got the address, awesome. Now what? How does your request actually get out of your computer or your phone and start its journey? Well, that all starts with the hardware that's probably sitting right there in the room with you.
So, your request kicks off its physical journey inside your device on something called the Network Interface Card, or NIC. From there, it travels either through a physical cable or wirelessly through an access point. Now, if you've got a bunch of stuff connected, like your computer, a printer, a smart TV, a switch acts like a local traffic cop, making sure your computer's request goes out the right exit and doesn't get tangled up with what your TV is streaming. And this is pretty much how it's all wired up. Most home and office networks use what's called a star layout. You've got this central device, a switch or a router, and everything else connects directly to it. It's a really smart design, because if one of those connections fails, it doesn't take down the whole network. It just affects that one device.
Okay, this is a big one. People get switches and routers mixed up all the time, but they have totally different jobs. A switch is purely a local traffic cop. It only handles traffic inside your own private network. The router, though, is the gatekeeper. It's the one and only on-ramp that connects your entire little neighborhood to the massive public superhighway that is the internet.
All right, we're on the move. Our request has just hit the router, and now it is officially out on the open road, the internet. It's now traveling on this huge global network, but it's not going as one big chunk of data. Nope, it's been broken down into something way smaller and way more efficient.
See, everything you send online gets chopped up into these tiny little things called data packets. Each one of these packets gets its own little address label, that IP address we found earlier. It's kind of like if you wanted to mail a book, but instead, you mailed it one page at a time, each in its own tiny envelope. It sounds weird, but it lets the network handle a mind-boggling amount of traffic all at once.
So you're probably wondering, how in the world do all these billions of little packets find their way? Well, that is the job of huge, incredibly powerful routers located all over the globe. These things are the brains of the internet. They're constantly talking to each other, figuring out the absolute fastest, least congested route for every single one of your packets to take to get where it's going.
You know, with all this data flying around, you'd think it would be total chaos, but it's not. To keep everything from becoming a massive digital traffic jam, all these data packets have to follow very strict rules of the road, or protocols. And the two main ones you need to know are called TCP and UDP.
Think of TCP as the super reliable, careful driver. It makes a formal connection, it double-checks that every single packet arrives, and it makes sure they're all put back in the right order. It's perfect for things where every piece of data is critical, like loading a website or sending an email. Then you've got UDP. This one's the speed demon. It just blasts the packets out as fast as it can and hopes for the best. This is great for things like live video chat or online gaming, where speed is everything, and losing a tiny bit of data here and there is no big deal.
And seriously, this is probably the best analogy ever for this.
TCP is like you carefully walking a sandwich over to your coworker to make sure it gets there perfectly. UDP, that's you just chucking it across the room. One is all about reliability, the other is all about speed. Different tools for different jobs.
Okay, let's take a breath and put this whole thing together. We've looked up the address with DNS, navigated the local network, jumped on to the global highway as tiny packets, and followed the rules of the road. Now, let's just sit back and appreciate the absolutely insane speed of this whole round trip.
Just look at this. It's wild. In way, way less time than it takes you to even blink. Your computer has this whole complex conversation with servers that could be on the other side of the world. From the moment you click to the very first piece of the website appearing on your screen is often less than 0.2 of a second. It's just an incredible feat of global engineering.
So what's the big takeaway here? Every single time you go online, you're kicking off a high-speed global relay race. Billions of these journeys are happening every single second, and together, they weave the fabric of our modern digital world.
And what's just mind-blowing is the hidden complexity behind that speed. Think about it. That first step alone, just finding the website's address, involves a perfectly coordinated dance between at least 4 different kinds of servers. 4! It's an amazing reminder of the invisible, powerful infrastructure that's working for us every single time we click a link.
So look, knowing how all this stuff works isn't just a fun piece of trivia. It shows you that your data goes on a really complex journey with a lot of different stops along the way. And every single one of those stops is a place where your data could potentially be looked at or messed with. So the real question is, now that you know the whole trip your data takes, how are you going to make sure it travels safely?